My background has historically been industrial wastewater, so I've been involved with multiple industries in performing anything from just basic waste characterization, treatability studies, whether it be bench scale, pilot scale, all the way up through full implementation, design, and construction activities. And then in addition to that, I've assisted a number of clients in optimization of their existing industrial wastewater treatment systems. So just a real brief background, Terra Aqua Resource Management, who we are, what we're about. Go ahead, sir. TARM, Terra Aqua Resource Management, is a wholly owned subsidiary of Larson Design Group. Larson Design Group is about 225, 230 person architectural engineering survey firm headquartered in Williamsport, PA. We've been there now for 25 years in one form or one capacity or another. We're a 100% employee owned firm. That kind of makes some of our culture the way it is. And then in addition to the employee ownership, there's about 55 to 60 shareholders that make up the balance of it. In addition to our headquarter office in Williamsport, about 140 of us sat there. We also have offices in Corning, New York, Bloomsburg, Columbia County, Selinsgrove, Snyder County, and then pushing further south and to the east, we're in Ephrata and Bethel, getting towards that Lancaster, York region down there. As Dave indicated, prior to 2008, really, we would have had zero activity in natural gas related activities. Simply didn't exist in our region. We're what I would designate as a mid-Atlantic firm, but our roots are definitely in the rural crossroads communities in north central Pennsylvania. Doing a lot of municipal water, sewer, streetscapes, traditional civil engineering work. Our first exposure to Marcellus was really through our clients, those public water suppliers and POTWs, where energy companies were approaching them. Can we get water? Can we give water? And so seeing that occur multiple occasions, the theme started to come out, and knowing that that region is regulated differently perhaps than some other areas of the Commonwealth, we began to take a look at what are the needs for our clients, and then at the same time, the challenges that the industry faces, how can we potentially assist them as well. So what we came up with is the critical need for the sustainable development of any unconventional natural gas is water resource management. That ability to obtain the fresh water and the ability to manage any generated waters. And by generated waters, just so we have shared definitions, I refer to generated waters as both flowback and produced waters from that well. I think everybody's probably aware the flowback is, somewhat immediate after the well has been fractured and flows back at the wellhead for a defined period of time. Most people, are the common time frame in which that transitions from flowback to produced water is when the gathering or midstream, the pipeline takeaway capacity, so that the well begins producing gas commercially. Then mainly just for accounting purposes, the industry now quantifies that as produced water. The volumes of water, everybody's probably familiar with that. You're talking anywhere from 3 to 5 million gallons of water to develop a single well. You may get in north central, northeastern Pennsylvania anywhere from 10 to 12% of that water back as flow back immediately. And in southwest Pennsylvania, that percentage is slightly higher. It might be 15 to 20% higher. The waste characterizations are different based on the geography where you're located, even though the geology, is presumably somewhat consistent. Geography does definitely change the characterization of the water that you see. So that was the first step that we had to understand very early on, is the flow back. What is it? What does it consist of? You know, why is it different potentially in Southwest PA, where it's designated as a liquids rich or a wet gas? In that area, you got various other hydrocarbons, as compared to the north central Pennsylvania region, which is a very dry gas. Almost out of the wellhead, it's pipeline spec ready that it can be introduced into the interstate pipelines. And then the outstanding question remains, where's that transition? Where does it go from dry gas to wet gas? Is it here in Center County? Is it further south and to the west? Because as a result of the different types of materials, the characterizations that you're dealing with, you have potentially different treatment strategies that apply to manage this water. A prototypical development plan by an energy company, you know, the first thing, of course, is they went out and large leases throughout the area. Then they started to configure it, how and where can I put well pads to optimize resource recovery. Larson Design Group participates in that effort with the engineer or with the energy companies to obtain all the well pad permits, all the E&S criteria to construct the well pads, as well as, you know, finding sources for fresh water, getting access to them, moving that water to the appropriate locations. And then started out back in 2008, and this time frame is getting compressed dramatically. From the time that they would have a well pad constructed, what they would designate as start to spud the well, it would on average take about 60 days. So from the time the rig came on, was set up on that well pad, started drilling, it would take about 60 days until they'd completed that well, including the hydraulic fracturing portion of it. A lot of that is just the logistics support, moving the volumes of water that they need, the volumes of sand, and you know, setting up a rig, breaking down a rig so that they can bring in a service company to do the hydrofracture. I'd submit to you that in the early portions of 2009 and even up through late 2010, this was still very much a, I don't want to say experimental, that wouldn't be the right term, but they were trying to determine where is the best location to do drilling. They were doing a lot of lease preservation, you know. Leases were conventionally signed for a 5-year interval of time. If they didn't access that property in that amount of time, that lease may expire. So a lot of things were done just to do lease preservation, as well as to try and put bookends on their reservoirs. And some of you may be familiar with the terminology. It's a common practice in the industry. What you want to do is go out and first identify your resource and what is potentially recoverable from that reservoir that you have the mineral rights to. So generally what they would do is they'd go out and do the microseismic activity, and that helps them define any irregularities in the formation, the target formation, if there's any faults or anything like that in those areas that they definitely want to avoid during well development. Once they would complete that, then they would drill just a couple pilot wells, and they would typically do 2 different wells, and they would call them bookends, and then everything in between they could go out to their investment group and say, we got whatever recoverable gas from well A and this amount of recoverable gas from well B. Everything in between is relatively consistent, therefore our estimate for recoverable hydrocarbon is whatever they calculate it to be. So that was kind of what was taking place definitely through 2009 and much throughout 2010. Now what you're starting to see is the commercialization of the natural gas development. Under no uncertain circumstances is it efficient to drill 1 well on a pad, break down the rig, move it to another location. Most pad sites are set up to drill anywhere from 6 to 10, maybe as many as 20 wells on a pad site. So where they're going now is they will set up that rig, drill all the wells on that pad site before they break down the rig, then bring in the service company to do the fracture of each well at that point in time. That's where they're going to gain efficiencies. So that 60 days is really getting down to about 30 days, even pushing 20 days from the time they spud till they've got that well completed. So as you can imagine, if you need 3 to 5 million gallons per well, plus all the other, supporting logistics associated with that, just magnify that when you're talking about completing an entire well pad as compared to just 1 or 2 wells on that site. The water management plan, that the energy companies needed to establish is where were they going to secure their sources for all this fresh water that they needed. Much of the early activity was they were purchasing it from public water suppliers. They had excess capacity, they were happy to sell it. It was easy to get regulatory approvals for that, so a lot of them were purchasing it. And then in the meantime, of course, they were going out and securing their own consumptive use surface water withdrawals so that they could pull water directly from streams, rivers, and in some cases lakes. And then really what it came down is, as you started putting it all together, this industry was a very reactive industry. They didn't do a lot of long-term planning initially, but when you started talking about needing to access tens of millions of gallons of water, stage it in an area so you can use it in a very short, compressed time frame, many companies needed to start, planning for that long-term sustained development program that they're having. And then the other aspect of it, at least from our perspective, being from north central Pennsylvania, very familiar with the regulatory climate and having secured, fresh water supplies for municipal clients as well as permitted publicly owned treatment works, wastewater treatment plants throughout that region, we were very much of the opinion that the ability to get fresh water was manageable. The ability to get rid of water, on the other hand, was another challenge and an unmet challenge for the industry. Through our observations, having participated in numerous workshops, conferences, and everything else, looking at other regions of the country where unconventional natural gas development has occurred, we're not in the Gulf Coast region where UICs, underground injection control wells, are prevalent. The geology supports, large volume disposals in wells. Pennsylvania has 7 commercial UICs. If the geology were capable of supporting it, we have a very industrial history in our Commonwealth that they would have been utilizing those, decades ago if it were viable. We'd worked with numerous clients to do injectivity testing, get them right to the point where they can take that next step with, in our case, the EPA, to permit underground injection well, and nobody ever advanced any of those opportunities. Basically, the outcome is they weren't obtaining the results that were desirable for economic viability of a UIC in our region. At the same time as we're seeing all of those factors come together, we were never of the opinion that it was sustainable to treat this water to the minimum degree that historically in western Pennsylvania, natural gas had been sent to numerous industrial waste treatment facilities, some POTWs, and with the large volumes now and then the different waste characterization, is that a sustainable practice for minimal treatment, discharging to a receiving stream, and then basically relying on the environment to do a lot of the dilution for the remaining constituents, predominantly the chlorides that are associated with the flow back in produced waters.